Here we go. The histogram shows the distribution of the distance in kilometers that students have to travel to school each day. First thing you need to do is you need to write down what is how many students have to travel from 0 to 2. That's 8. How many of them have to travel from 2 to 4? I say that's 6. 4 to 6 is 8. 6 to 8 is 12. From 8 to 10 is 6. And finally from 10 to 12 is 32. Okay? Now, what happens next is complete the corresponding frequency distribution table. So it's going to be 8, 6, 8, 12, 6 and 32. It's the first part done. Next part. Assume that data can be taken at the mid-interval values. Calculate the mean to the nearest integer. So what I'm going to do here is going to put that to 1. This to 3. That's the middle of the interval. The middle of 4 and 6 is 5. The middle of 6 and 8 is 7. Middle of 8 and 10 is 9. Middle of 10 to 12 is 11. You now got to go about calculating the mean and the standard deviation. So you're going to press mode, stat, 1 variable. Okay. Now you do 1 variable. So we got to calculate the standard deviation. You notice my frequency is off at the moment, so to sort that out I have to go to shift, setup, go down, stat, frequency on. I'll go in again then, okay? Mode, stat, 1 variable. I'm going to put in the numbers, right? So it's going to be, 8? Oh, sorry, that's wrong. It's going to be 1, 3, 5, 7, 9 and 11. On the other side, it's going to be 8, 6, 8, 12, 6, and 32. Save it there. Go to shift, stat, go to variables. The mean is going to be 7.72. So people got. So the mean or the average is 7.72. Now this next part is the standard deviation. Knock it off, shift, stat, 4, the third one for standard deviation. Standard deviation is 3.56. Okay? Now, what's asked me next is, done that one. Estimate the percentage of students, not the total number of students, the percentage of students to the nearest integer who have travelled a distance within 1 standard deviation of the mean. Now 1 standard deviation of the mean means the people who got 1 standard deviation below the mean is 7.72 minus 3.56. That gets me, anybody? 4.44. And then I need 1 standard deviation above the mean, which is 7.72 plus 3.56, which is 4.16. Oh, sorry, 4.16. It's okay. And what's the other one? 4.16 in the second one?
11.28.
11.28. Now, what it's basically asked me to do is, it's asked me to figure out how many people are between 4.16 and 11.28, which is over here. So to do this, what we have to do is we have to figure out there's going to be 2 rectangles that aren't complete. Okay, and I'll show you what I mean by that now. This rectangle here that used to have 8 people in it, no longer, I'm going to shade it in green. This green rectangle hasn't got 8 people in it. It has a number smaller than 8. To figure out what that number is, what I do is I get I actually figure out how much distance is it from 4.6 to 6. 4.16 to 6 is 1.84. The interval is usually 2 wide, so it's 1.84 divided by 2. That's the fraction of the area we have. So it's 1.84 divided by 2. How many people is there in total in that rectangle? Usually 8. Put that into your calculator and it'll tell me how many people are in the green rectangle. Can anybody tell me? 7.36. Okay. Now lads, the next one is the next one I really have to worry about is this rectangle up here. It's not a full one either. So I'm going to do is going to shade this one in red. Now, how many people are usually in this rectangle? Like the full rectangle? 32. Now it's usually 32, but obviously the red area isn't all 32 people. It's a fraction of the 32 people. So what we're going to do is the usual length is 2. From 10 to 12 is 2. Now we're stopping at 11.28. So how much of the bottom do we have? What's the width basically? 1.28. Get 1.28 divided by 2 and multiply by 32, and what do we get? It should be a number over 20, I reckon, because it's most the rectangle. 20.48. Yeah. Now, in the green rectangle, there's 7.36. In the red rectangle, there's 20.48 people. In this rectangle here, there's still 12, and there's still 6. So what we're going to do is we're going to add them all up now. So we're going to get it's 8 and 12. 12 and 6 are the two middle ones. 12 plus 6. And the green rectangle, which is from 4.16 to 6, is 7.36 people. And the last rectangle, which is from 10 to 11.28, contains 20.48 people. Now what happens when you add them all together? What you get? 45.84 people. That's how many people got between these two scores. That's how many people got from 4.16 all the way to 11.28. Now that's not what it's asking us for. It's asking us for the percentage of people. How do you get percentage of people again, lads? Multiply by 100 over 1. But what do you have to divide it by? The total number of people. What's the total number of people? When you add 8 plus 6 plus 8 plus 12 plus 6 plus 32, what is it? 72. 72. Now put this into your calculator and tell me what you get.
63.6.
Is that right? 63.6%? It'll be over 50% because it's above halfway. So Jack.
Is it halfway 46?
45. Okay, guys. Next one. What we're doing here is the distribution of contributions in euro given by a charity by a number of people is shown in the histogram below. So if you're in business, you'll often be asked to produce something like this to show who you're working for, the stats. Okay, it's very easily interpreted. 12 people gave 0 to 10,000. 30 people gave 0 to 20,000. 12 people 20 to 30,000. Halfway between 24 and 30 is 27, so 27 people gave 30 to 40, and then finally 40 to 50 is I'm just going to draw a line going across because I can't really make it out. I think it's going to be 9. Okay, so 9 people. Now what we're going to do next is we're going to fill this out. Jordan. Okay, next thing we're going to do is 12, 30, 12, 27 and 9. By taking the mid-interval values, find the mean and find the standard deviation. Okay, it's going to be 5, it's going to be 15, halfway from 20 to 30 is 25, 35 and 45. Now, what we're doing next is we're once again just going to use the calculator. We're going to go into stat mode, one variable, and we're going to put in our numbers, okay? So it's going to be 5, 15, 25, 35, 45. On the other side, it's going to be 12, 30, 12, 27, and 9. Okay? Then we're done with this. Shift, stat. What we're going to do is the variables. Number 4, our mean turns out to be 24. Our mean is 24. And our standard deviation, which will be shift stat variable number 3, is going to be 12.48. Okay, so I'll round off to 12.48. Okay, I want it to the nearest euro, which means I'm going to use 12 because it wants it to the nearest euro. Now, just for the sake of it, okay guys, I'm just going to add in my own question, number 4, just so we get practice at it, okay? What I'm going to ask you is I'm going to ask you the same question I did in the last one. I'm going to ask you is what percentage of people donate within one standard deviation, okay? So what percentage of people donated within one standard deviation of the mean, okay? Now, what we're going to do is we're going to use 12, all right, and not 12. We're not going to use. We're just going to use 12, okay, as the standard deviation. Now, what is mu minus the standard deviation? What's the mean minus the standard deviation? 24 minus 12. Your first idea is to put up your first line, okay, at 12. That's your first line at 12, okay? Find next, what is the standard deviation plus the min? 36. Put another line up at 36. Okay, around here. Your job is to find out how many people are in between those two vertical lines. Now, you know that the 12 in the middle is grand because it's the full rectangle. There are 12 people. What I'm going to do, however, is I'm going to have a red rectangle. I won't shade it all the way to the bottom, and a green rectangle. Now, to get how many people are in the red rectangle, what we have to do is we have to figure out how wide is the base. So what's the distance from 12 to 20? 12 to 20 is 8. What is usually the width? 10. It's 8/10 of your 30 people. So 8/10 of your 30 people are in that red rectangle. Okay? That's going to give you 24 people. Is that alright? In the next one, which is the green rectangle, what is the width? 30 to 36 is 6. It's going to be 6 out of 10 times how many people are usually in that one? 27. So what's 6/10 of 27?
16.2.
Was it?
16.2.
16.2. So there's 24 in this one, 16.2 in this one, and how many people in the middle one? 12. So add them all together. And what do we get? 52.2. Okay, 52.2, well done, Jack. How many people is there in total? Where we want the percentage. So 52.2 people out of how many? 42, 54, 81, 90. Out of 90 people. Okay? Multiply by 100 over 1, and this will tell us what percentage we're at.
58%.
Was it?
58%.
58% of all people donated within one standard deviation of the mean. You're guaranteed to be asked that question tomorrow. Okay? Guaranteed. Now, you interview 2 people from the group, and this is just a common sense question, right? This is really sense, and do you actually know what the chart means and what's going on? Okay? You interview 2 people from the group of people who made a contribution to the charity. The 2 people interviewed claim to have donated a total of 150. 2 people donated €150. What's the average they donated per person? 2 people. 2 people donated €150. What's the average of 2 people? €75. Can anybody tell me what's wrong with that? Look at the top. Is there anybody who's donated €75 according to this data? No. Okay? So therefore, this is highly unlikely, as in fact I'd say it's impossible, because people who donated over €50 are non-existent. They're not recorded in the data. That's why this claim must be impossible according to our data. Okay?